All right, welcome everybody to Accuplacer Math Crash Course Day 3. We've got Kiesia with us. Say hi to everybody, Kiesia.
Hello.
Thank you so much. All right, and today we're doing things a little bit differently. I know for the first 2 days of the course we started working on rules 1 and 2. Today we're going to go to rule 3 of Accuplacer Math. So actually I'm going to turn to that right now, go to those rules. And we've been doing logic and estimation and using process of elimination. But Kiesia, I would love it if you would read for us rule number 3. It is maybe the most important strategy. Let me rephrase this. It is definitely the most important strategy I can teach you for your success on the Accuplacer. And it's going to account for, like maybe half the questions that you're going to answer and get right. Go ahead and read rule number 3 for us, please, Kiesia.
Avoid algebra whenever possible. Instead, plug in values for the variables and solve.
Yeah, avoid algebra if you can, right? There's a way of approaching these questions that you can turn a lot of them into basic arithmetic, okay? Don't go into algebra mode. Don't start isolating variables if you don't have to, and generally you don't. You can plug in values in place of the variables and find the answer really easily using like middle school math, okay? And I'm going to show you exactly what that looks like. So let's jump into some questions, and we've got a question up on the screen right now. So go ahead and read question number 1 for us, and we'll apply that rule.
Which of the following expressions is 5 times as much as the sum of r and s?
Okay, which of the following expressions is 5 times as much as the sum of r and s? Okay. Now, I don't know if you're anything like me, Kiesia, but I get confused easily when I'm dealing with variables. Okay, like even just hearing that question, I'm not sure exactly what they're saying. I'm not certain. So I want to plug in some values for r and s. I don't want to deal with r and s. I want to deal with actual numbers here. Okay. So let's set some values right off the bat. Okay. And you can pick some different values here. I like starting with smaller values. I think that makes life a lot easier. So I'm going to make r equal 1, and I'm going to make s equal 1. Okay. I can make r1 and s2. I can make r2 and s3. I can pick different values. I just like starting small, and that's going to make the arithmetic a lot easier. Okay. Now the question is different. Okay. Now that we've set some values for r and s, it's not which of the following expressions is 5 times as much as the sum of r and s. It's which of the following expressions is 5 times as much as the sum of 1 and 1. Does that make sense how we can just kind of plug those values in now that we've set them into the question? Does that make sense, Kiesia?
Yes, sir.
Okay, now, so let's answer that question. What is 5 times the sum of 1 and 1?
It'll be 5, huh?
Well, 5 times the sum of 1 and 1. Let's talk about what sum means. What does sum mean?
Equal, right?
Sum means addition, right? If I said, like, what's the sum of 2 and 3, right? Sum means altogether, right? Think of, like, the summary of a book, right? Summary, like, altogether, what's the main point, right? That's the sum. So sum means, when we see that term, on a test, that means you're going to be doing addition. If we saw a difference, like what's the difference between, 10 and 7, the difference, that means subtraction. And that would be, the difference between 10 and 7 would be 3. Which also kind of makes sense on like a logical level, but just know it also means subtraction. Okay, you've heard that before, probably through like middle school math classes, right? Sums, like do you know your sums, right? Have you heard that term before, right? Yeah, it just means addition. So what is the sum of 1 and 1?
2.
Yeah, sum of 1 and 1 is 2. So r plus s is 2, and then they're asking us now, what's 5 times the sum of, or what's 5 times 2, right? When r is 1 and s is 1. Does that make sense?
Yes.
So what's that? What's the answer, by the way? It's just 5 times 2.
10.
And that's 10, right? So does that make sense why 5 times the sum of r and s is 10 when r is 1 and s is 1? Does that make sense?
Yes.
Okay, great. Now all we got to do is take those values, plug them back into the answer choices, and see which answer choice gives us 10. Okay? So let's test these answer choices. I'd love to see you do this on the whiteboard if you could. Maybe I'm going to scroll a little bit over, maybe just to the left of the problem, if you can kind of work these out. We're probably going to practice some order of operations stuff here, maybe some Pemdas. Are you familiar with Pemdas, Kiesia? Is it familiar?
I don't know. I've heard to see that.
Yeah. We'll go over it. We'll go over it together. I'll show you exactly what that looks like. But go ahead and plug in. Let's plug in a 1 for r and a 1 for s, and then we'll see which answer choice gives us 10. Okay? Looking good. Okay, great. Now I'm going to stop you real quick. Before you
Okay.
calculate anything. Okay, before you calculate anything. So we got 5 times 1 plus 1. Okay. Now what do you do first? Do you do the multiplication first? Do you do the addition first? What do you do first here? I think that's kind of the question. Okay. And this is where Pemdas comes in handy. Okay. Do you know which one you do? Do you know which one you do first?
Yes.
Which one do you do first?
Multiplication.
Absolutely, right? Absolutely. Let's review that real quick. Let's review PEMDAS just for anybody watching the recording here, and we're going to come back to this because I think we're going to need it throughout all this question. I've got PEMDAS on my rules for Accuplacer Math. It's the last thing on the cheat sheet. So PEMDAS is the order with which you need to simplify expressions. Okay, it's an acronym. The P stands for parentheses, E is exponents, multiplication is M, the D is division, then addition and subtraction. Okay, so you've got to go in that order. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. And if you go do some calculation outside that order, you're going to kind of mess everything up. Okay, so you got to make sure we're following that order. Let's go back to the question. So we don't see any parentheses here. There's no exponents here. So we can jump right into the multiplication. Okay, so let's multiply 5 times 1. What's that?
5.
That's 5, right? And then add the 1 now. And what does that give us?
6.
Okay. Is that what you thought the answer was, by the way?
Yes, sir.
Okay, excellent. Okay. Some people have been doing it all along and didn't realize they were doing PEMDAS, and that's if you got it down, if you don't mess up, simplification of expressions, wonderful. But a lot of students really benefit from thinking in terms of PEMDAS, parentheses, exponents.
Yeah, I never just heard no one call that. That's why I was like, well, what is that?
Oh, that's funny, right? So
I know what it is.
you've been doing it, right? Isn't that funny? You've been doing it. But in case you're ever confused about it, always, then you can reference it. Always start with parentheses, then exponents, then multiplication, division, addition, and subtraction. Hugely important on this test. Hugely important, especially with this strategy we're using. We're going to turn everything into arithmetic, so you have to have PEMDAS down. All right, so 6 doesn't equal 10, very simply, so it can't be answer choice A. Does that make sense?
Yes.
Okay, excellent. I'm going to clear some screen here on the whiteboard. Let me see you plug in 1 for R and 1 for S in answer choice B. Let's see what that looks like. All right, we don't even need to PEMDAS that, right? It's just addition. So what's that equal?
7.
That's crazy. That doesn't equal 10, so we don't have to worry about answer choice B. That's gone. And what about answer choice C? Let me clear some room on the screen. And then plug them in answer choice C. Looking good. Again, PEMDAS that.
That'll be 6, huh?
And that's going to be 6 as well. Mm-hmm. Yep, that's going to be 6 as well. So it can't be C. I sure hope D works. Let me clear some space for you again, and then plug a 1 in for R and a 1 in for S into answer choice D. Okay, now let's think in terms of PEMDAS here again, right? Because you start with what's in the parentheses. Okay?
Right.
So calculate what's in the parentheses. Easy, right? Absolutely. And now we can do the multiplication. It's looking good. Beautiful. 10. It's the only one that gives you 10 when you follow PEMDAS. Okay?
Yes.
So we can confirm it's indeed answer choice. Answer choice D. Any questions about that, Keisha?
No.
Okay. I mean, you can think about that in algebraic terms if you want to. If you can find the answer choice, think in terms of the variables. I'm down with whatever gives you the right answer. But I think turning everything into arithmetic is going to be the easiest way for the vast majority of students. That's been my experience.
Yeah.
Okay. All right. Let's do the next question. And pretty much all of them today we're going to be using this strategy. It just applies to so many questions. All right. Let's see. The second guy here. All right. And go ahead and read question number 9 for us when you see that on the whiteboard, Keisha.
X to the second plus 5x minus 9 equals 5. Which of the following values of x satisfies the equation above?
Okay. What are we solving for here, Keisha? Let's make that really, really clear.
Which of the following equations satisfies x?
Yeah, well, not which of the following equations, right? Which of the following values, right? I mean, we've got, and I know that's what you meant. We've got 4 answer choices here that are all potential values for x. Okay. Now we're going to plug in values here. Okay, but we don't have to come up with our own values, right? Because I know that x is either going to be 7 or 3 or -2 or -7. It can't be anything else. Does that make sense?
Yes.
I get this question from a lot of students that use my plug-in and value strategy. And it's got, I mean, I get messages from every day from students that are passing tests using the strategy. So, I mean, there's no question in my mind that it works. But some ask, like, how do you know which values to plug in? And I say, generally, if you're plugging in your own values, always start with smaller values, kind of like we did on the last question. But if they ask you, like, which of the following values satisfies the equation, you don't have a choice. You've got to plug in the answer choices. Okay? So let's plug them in. There's going to be 1 answer choice that works, 3 that don't. Let's test them. So go ahead and plug in a 7 for x. You can just work, on a space below the question. That'd be great. And we'll plug them in and see which gives us a true statement. Okay?
Okay. Yeah.
Excellent. And I love that you're putting that 7 in parentheses. You don't need to with 7 squared. That's fine. But when I'm plugging in, I love putting parentheses around the thing I'm plugging in just so that, especially if it's a negative number, right? I don't turn like what should be multiplication into subtraction or something like that. So I recommend that. That's good. Okay, let's think in terms of PEMDAS again as we're kind of simplifying this. There's nothing to calculate in the parentheses. I know there's a 7 there that's in parentheses, but there's nothing to, I'm not adding or subtracting or multiplying within the parentheses. So I'd start with the exponents here. 7 is raised to the power of 2. What does 7 raised to the power of 2 mean, by the way?
7 times 7.
7 times 7, absolutely. Do you know what 7 times 7 is?
Yes.
Okay. Let's simplify it.
49.
Yep. And I'm guessing they would give you the on-screen calculator on a question like this. I'm guessing you'd have access to that. Do you recall when you've taken these tests whether you had a calculator on most of the questions? Do you recall? Or maybe you didn't notice.
They did give me the calculator, but it was like, I don't know, it was a little bit all over the place when they gave me the calculator.
Yeah, you never do. Yeah, I got you. All right. 5 times 7, you have 5 times 7?
30.
Yeah. Equals 5. Now I'm going to stop you real quick because I think the temptation here, Kiesha, very understandably, is to like, okay, I'm going to add 49 and 35, which if you got to calculate, it's no problem. Just go ahead and calculate it. Great. But like if you're doing it on your own, it takes some time and it's easy. The more operations you're doing, the easier it is to make a silly mistake. Don't even worry about calculating here. Okay. We don't have to find out what the left-hand side of that equation equals. All right. The question is, does that left-hand side of the equation equal 5? Do you understand what I'm saying, Kiesha?
Yes, sir.
Yeah. Is that going to equal 5? The left-hand side of that equation? No, that's crazy. It's going to be way too big. Way too big. Yeah. Don't even worry about calculating it. Okay. And that's where you can, the rules kind of work together. You can use a lot of estimation when you're plugging in values and use a lot of common sense when you're plugging in values. And sometimes without even calculating what a particular answer choice is going to give you, can be like, there's no way that's going to work. That's just way off. Okay?
Mm-hmm.
So let's get rid of answer choice A. Adios, it is gone.
Okay.
All right, so let's try a 3. Let's see if 3 works. So plug in a 3 for x. Looking good. All right. So let's do PEMDAS again, right? Exponents first. Simplify this. All right. Does that give us a true statement, Kiesha?
I don't
No way. I mean, we could calculate it, right? I mean, the nice thing about this, we got 9 here and negative 9 here. That's going to cancel each other out. You know what I'm saying?
Yes.
9 minus 9 is, nothing.
So then it wouldn't.
Yeah, 15 doesn't equal 5 very simply. So we can also eliminate answer choice B. It's either C or D, all right? So let's plug these in. Now, be careful when you plug these in here. I'm going to really recommend that you plug them in parentheses, right? Plug them in parentheses. Super important when you're plugging in values, especially if we're dealing with exponents, which we are here. I'll show you why in just a minute. Let's go and plug in that negative 2 for x. Let's see what happens. It's looking good, looking very, very good. All right, very good. All right, you're getting good with that mouse. Okay, so let's do PEMDAS again. We'll start with, there's nothing to calculate within the parentheses, but let's do the exponents. So what is negative 2 squared?
It'll be a positive 4, huh?
It's going to be positive 4, absolutely right, because a negative times a negative is a positive. Don't forget that, okay? And this is where I want to point some out. I'm going to stop you for just a minute, just for anybody watching the recording, for you too, for that matter. If you wrote negative 2 without parentheses squared, negative 2 without parentheses, that equals negative 4. Okay? That equals negative 4 because that means negative 2 squared. 2 squared is just 4, so it's negative 4. Okay? And that's different from that, put in parentheses. That's negative 2 times negative 2. You see the difference between those?
Yes, sir.
Okay, and that some students are usually confused about it, but if I saw like 1 minus 2 squared, right, that's going to be negative 3, right, because that's 1 minus 4. That's right. 1 minus 4. Does that make sense?
Yes, sir.
Yeah, so if you're plugging in negative 2, you got to put it in parentheses like you did. Just want to make a note of that and throw some students off. So, all right, so we've got 4 plus, and then what's 5 times negative 2?
Negative 10.
Negative 10, right? A positive times a negative is always negative. Minus 9. All right, looking good. Okay, now I'm going to stop you real quick before we try to calculate that, because especially when you've got negative numbers, it can be a little bit confusing, especially the negative numbers are more negative than the positive numbers are positive, which is the case here. Is that going to equal 5, the left-hand side of that equation, Kiesha? And we can calculate it if we need to. If you're not sure, don't just guess. You know what I'm saying? You want to calculate it?
Yeah.
Let's calculate it. What's 4 minus 10?
4 minus 10?
Mm-hmm.
Negative 6.
Negative 6, absolutely. Absolutely. So I would simplify one thing at a time. You know what I'm saying? Just do 4 minus 10 first. Beautiful. Very nice. Minus 9.
Okay.
Minus 9. Okay, now you can probably look at it and ask yourself, is that going to be a true statement? Negative 6 minus 9.
No.
No way. That's going to be negative, right? Right?
Right.
I mean, if you have like negative $6 in a bank account, God forbid. Okay, I guess it could be worse. It could be worse, right? But and this is why I love thinking in concrete terms, Kiesha. Make this stuff as concrete as you can. Don't just swim around in math theory in your head. You know what I'm saying? Make it real. Make it concrete. You have negative $6 in your bank account. Got to help you. Mm-hmm. Okay? And then you take away $9 more. How much are you going to have in your bank account? It's going to be negative, right? You got nothing. You're taking away more. What is that going to be, by the way? Do you know what negative 6 minus 9 is?
Maybe, negative 15.
It's going to be negative 15. Absolutely. Negative 15. Yeah, you got negative 6 and you're taking away 9 more? And if you need to use your fingers and count back 9, you can do that. You know what I'm saying? Be okay, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15. Count back if you need to. But make it concrete. Absolutely. So that's going to be negative 15 is equal to negative, or is equal to 5, which obviously is not a true statement. So we can eliminate C as well. Okay? In theory, we could stop there. Right? Because we know A doesn't work, we know B doesn't work, we know C doesn't work. In theory. I don't recommend it. I'd recommend confirming D You know what I'm saying? You've got all the time in the world. This is an untimed test. Man, I got an email from a student not too long ago who said she spent like 6 or 7 hours working on a test. And I was glad. Like, great. She was taking her time. So let's confirm it. Let's plug in that -7. Remember, let's use those parentheses. Plug in -7, see if we get a true statement. I sure hope we do. I don't have the answer key in front of me, so I sure hope this works. But I think it will. Looking good. Using those parentheses. Beautiful, Keisha. Awesome. All right, looking good. All right, Pemdas again. Nothing to calculate in the parentheses. Let's go to the exponents. Love it. Positive 49, very nice. Negative times a negative is always a positive. You could say plus negative, you know, but I like what I do what you're doing, right? Just make it negative. You know what I'm saying? Just make it minus.
Yes.
Yeah. Okay. Does that look reasonable?
Yeah, if you subtract 49 minus 35.
Yeah. Yeah. You know what's 49 minus 35?
14.
Double check that.
Okay.
Oh, no. You're right. I'm sorry. I was wrong.
Oh.
You're right. I'm sorry.
Okay.
It's been a long... been tutoring all day. It might not be the last time I make a silly mistake. You are right. You're good. Excellent. Keep going.
This would be 5.
And that's going to be 5. Absolutely. So we can confirm indeed it is answer choice D. All right. Any questions about that, Keisha?
No, sir.
Okay. I mean, do you see how you just don't have to get fancy with that equation up there? You know, you could like subtract 5 from both sides and try to factor in. You could do it. There's just no need. Just plug in the answer choices, man. Just plug them in. Test them. Okay. All right. Let's do some more. All right. Plugging in values. All right. Question number 10. Go ahead and read this for me, please.
Oh, how would I write? Would it be like to the square root?
Yep. I'd say the square root of 5 minus x. Mm-hmm.
Okay. If the square root of 5 minus x equals 4, then x
equals something. All right, and it equals one of these 4 things, right? Equals one of those 4 things. So
I've seen a lot of these questions on TSI.
You saw them on the TSI? Yeah, absolutely.
Yes.
Right. And for anybody watching the recording, you know, TSI is basically, it's the Texas version of the Accuplacer. You know, I've got the TSI videos on YouTube as well. So, and they give you the answer choices on questions like this?
Yes, sir.
Yeah, okay, great. Like, be so thankful when you see a question like this. It looks scary, but if you're plugging in values in place of variables, it's just arithmetic. That's all it is. Real easy. Okay. So, let's just plug them in. Okay, we'll plug in the answer choices in place of x. I recommend doing the same thing that we did the last time, where we put parentheses when we're plugging them in, just to keep all the negatives straight and everything. So let's do that. Go ahead and plug those in, and we'll test them all.
Okay.
All right. Looking good. I'm going to make sure that square root sign kind of goes all the way across as well. Okay. So we've got the square root of 5 minus 21 is equal to 4. Okay. Let's simplify this now. Okay. Let's simplify this. What's 5 minus negative 21? You know what that is?
5 minus
Mm-hmm.
would be negative 16.
So when 5 minus 21 would be negative 16. 5 minus 21 would be negative 16. This isn't going to be negative. When you take away a negative, when you subtract a negative, you're adding. Okay? Think about it this way, Keisha. Here's what I was thinking about. Again, I love making it concrete. Okay? Let me make it concrete. Let's say you have negative $21 in your bank account. Okay? Negative 20. You're in debt. Okay, $21. Negative $21 in your bank account. Let's say I'm just feeling generous today, Acacia. I'm gonna take away your debt. I'm gonna take away your negative $21 from your bank account. I'm gonna take it away. Take away your negatives. I'm adding that to your bank account. You see that? If I take away your negative $21, if I take away your $21 in debt, I'm adding to your bank account. Does that make sense, Keisha?
Yes.
When you take away a negative, it's adding. Let's say you got something negative in your life, Keisha. You got some negative. You got a bad ex-boyfriend. Okay? Do you have a bad ex-boyfriend?
No.
No? Okay. But imagine if you did. Imagine if you did. Some negative, right? Something negative in your life. If somehow that was removed from your life, if that was taken away from your life, okay? That'd be like something positive happening. You know what I'm saying?
Yeah.
Okay. All right. So anyway, taking away negative is adding. So what's 5 minus negative 21? What is that?
5 minus negative 21.
It's the same as 5 plus 21.
What, 26?
26, absolutely. So it's the square root of 26. Equals 4. Does that make sense? Why those are equal, those two statements?
What, 26 equals 4?
Well, I'm saying, does that make sense why that equals that? Why 5 minus negative 21 is the same as 26? Okay. Now, the question is, does the square root of 26 equal 4? That's the question. Do you know if the square root of 26 equals 4? I don't think it does either. I don't think it does. There are a couple ways we can look at this. I mean, if you have a calculator on screen, wonderfully, just calculate the square root of 26, see if it equals 4. Easy. Okay. If you don't, we've got some options. We can think about this sort of logically. Okay. I've never seen, there's some common, let's talk about what it means to find square root. Okay. What's the square root? This is not directly related to the question. We're practicing square roots. What's the square root of 9 equal?
3.
It's 3, right? Because that square root sign, it means there's some number. When you multiply it by itself, it gives you 9. And that number is 3. Okay. Guess what the square root of, let's do another one. Let's do the square root of 16. What's the square root of 16?
4.
It's 4, right? The square root of 16 is 4 because there's some number. When you multiply it by itself, it gives you 16, and that number is 4. Does that make sense?
Yes.
Let's keep going. What's the square root of 25? These are just common kind of square roots.
5.
Yeah, square root of 25 is 5 because there's some number when you multiply it by itself gives you 25, and that number is 5. Does that make sense, Keisha?
Yes, sir.
Okay. So just looking at this now, first of all, we just calculated the square root of 16, which was 4. And because the square root of 16 is 4, and some of you know that, you might have known that, right? That's where you already did. In fact, I asked you, and you knew the answer. The square root of 16 is 4, so the square root of 26 can't be 4. The square root of 16 is 4.
Right.
Does that make sense?
Yes.
Focus on what you know on this test. Okay? Don't focus on what you don't know. I don't know what the square root of 26 is. I don't think anybody watching this video knows what the square root of 26 is. Nobody knows. All right, I mean, you can punch your calculator to find out. But I don't know what it is offhand. I didn't memorize it. It's some weird decimal thing that goes on forever, probably. So, but it's not 4 because the square root of 16 is 4. And even, I know the square root of 25. Most people know that. The square root of 25 is 5. And so the square root of 26 is going to be something a little bit bigger than 5. Either way you look at it, it's not 4. Does that make sense, Keisha?
Yes, sir.
So important. Focus on what you know, not what you don't know. And quite often, if you just focus on that, you don't have to know everything for this test. You just have to know enough to get rid of the wrong answer choices and confirm the right one. And we know enough to eliminate A. It can't be A. Does that make sense?
Yes, sir.
Awesome. Let's plug in negative 11. See what happens. Great use of the parentheses there. All right, so we got 5 minus negative 11. What's 5 minus negative 11?
16.
It's 16, absolutely, right? Because when you take away a negative, when you subtract a negative, it's the same as adding. So that's the same as 5 plus 11. 5 plus 11 is indeed
Correct.
16. So it's the square root of 16 equals 4. Does that give us a true statement?
Yes.
Absolutely. We just went over that. It's B. I don't think there's any question about that. It's B. Okay. If you wanted to, and I'd probably recommend it, test answer choice C and D, just to make sure you're on the right track. You know what I'm saying?
Mm-hmm.
Just to make sure, because it's easy to make silly mistakes. But if you can get rid of A and C and D and confirm B, you can be very confident in that. Very confident in that. But if, like, let's say you get rid of A and B and C and D, then you're like, okay, I made a mistake somewhere. Let me redo it. Let me go over it again. Extra careful. See if I can catch my mistake. You know, I feel pretty confident about these. And I'm looking at them right now. You know, if I plugged in a 1 for X, I'd get the square root of 5 minus 1. What's 5 minus 1?
6.
Well, what's 5 minus 1?
4.
5 minus 1 is 4, right? I get the square root of 4 equals 4, and we know that's not true. Because what's the square root of 4?
2.
It's 2, right? Not 4. So C is gone. That was easy. And let's plug in 11 as well, right? So do you know what 5 minus 11 is?
It's -6.
-6, absolutely. Square root of -6 equals 4. That's not right either, right? I mean, you can't find the square root of negative numbers.
Right.
That's not a thing. Because there's no number times itself that's going to give you -6, right? Because if it's positive, it's not going to be negative, because positive times positive is positive. But even if the number is negative, a negative times negative is also positive, so you can't find the square root of negative numbers. So there's no way it's going to be D, and it's not. Any questions about that?
No, sir.
All right. You got this. Let's do some more. I think that was the third one we did. Ooh, this one's a little bit trickier. This one's a little bit trickier. Go and read number 11 for us, please.
If x minus 1 over x equals 20, then x equals what?
Okay. All right. Now, the way to do this algebraically, you know, you can isolate x. Gosh, it's complicated. You guys got to multiply both sides by x, and it gets complicated. It's not terrible, but I mean, it's algebra, okay, which we're trying to avoid, which I recommend.
Yes.
Okay, so let's test the answer choices. And this is a great example of one of those questions where you don't have to know everything. You just have to know enough to either eliminate all the wrong ones or confirm the right one. Okay, we don't have to know everything here. Let's plug these in and see if we can start eliminating some bad answer choices. Okay, so go ahead and plug in that -21 in for x here. Let's see what happens. Okay. All right. Let's simplify this. What's a -21 minus 1?
21.
That'd be negative.
You said -21 minus 1?
Oh,
I was multiplying.
Yeah, multiply. Absolutely, right. Here we're subtracting. Do you see, by the way, do you see why we're subtracting here?
Yeah.
Right? If that was in parentheses, okay, you're multiplying, but it's not in parentheses. It's just -21 minus 1. So what's -21 minus 1?
-22.
-22, absolutely, right? You got -$21 in your bank account. You take away another dollar, you got -$22 in your bank account. So that's -22 over -21 equals 20. Now, before we calculate that, look, I don't know what -22 divided by -21 is. I have no clue. But I don't care. Is that going to give me 20?
No.
There is no freaking way it's going to give me 20. Okay. Does that make sense when I say you don't have to know everything? Just focus on what you do know. And you know that anything divided by itself is 1. And that's going to be this is really close to something being divided by itself. That's going to be something close to 1. Probably just a tad bigger than 1. But it's not going to be 20. The thing in the numerator would have to be like 20 times the thing, in the denominator. And here it's not. So we can eliminate A. Does that make sense why we can eliminate A?
Yes.
Awesome. Let's plug in a -19. Looking good. All right. Let's do it again. Let's simplify again. What's negative 19 minus 1?
Negative 20.
Yeah, negative 20. That's negative 20 in the numerator divided by negative 19. We don't have to change that. Okay. Is that going to be a true statement, Kiesia?
No.
No. No. No. Right? I mean, it's similar to the last one, right? These numbers are so close to each other, and something divided by itself is 1. So that's going to be closer to 1.
Right.
It's not going to be 20. Remember, the thing in the numerator has got to be 20 times the thing in the denominator.
Okay.
You know what I'm saying? Like 40 divided by 2 is 20. Or like 60 divided by 3 is 20, because the thing in the numerator is 20 times the thing in the denominator. That's just not going to be a true statement. Does that make sense?
Yes.
Great. A and B are gone. If this is as far as you get, I'm okay with that. Because you got a 50-50 shot now in a tough question. This is a tough question, even when you're plugging in values. Because now you got to plug in some fractions here. You know what I'm saying?
Mm-hmm.
So if you've got to guess between C and D now, I'm okay with that. I don't think we have to stop there. In fact, I know we don't. Because I think we can plug these in and find out which one gives us a true statement or which one doesn't give us a true statement. So plug in negative 1 over 19 in for x. Let's see what happens. Excellent. Great. Love use of parentheses. Excellent. All right. Now, this is intimidating looking, right? I mean, you look at it, you're like, oh, I don't know how to process this. Don't worry about it. I don't think we even have to calculate it.
Okay.
I don't think we have to calculate it. We may. We may. Here's my question. Is that going to be positive or negative on the left-hand side? On the left-hand side.
I would say negative.
Why negative?
I don't know, because I'm looking at this fraction. It's just like...
Because there's a lot of negatives, right?
Yeah.
Let's do this.
1 over 19. So I just look... I don't know.
All right.
I don't know how this
Let's do this. Let's do this. Is the numerator going to be positive or negative? Is the numerator?
Negative.
It's going to be negative, right? The numerator is going to be negative. That's going to be negative. You got negative $19, negative 1 over $19. That's like some 20 cents or not even that. 5 cents, negative 5 cents. Don't worry about that. You got something negative, right? A little fraction.
Mm-hmm.
And then you take away something else. You take away even more. It's going to be negative, right? It's going to be negative. And then the denominator is negative as well, right?
Right.
The denominator is negative as well.
Oh.
So you have a negative divided by a negative. Is that going to be positive?
Yes.
It's going to be positive. Okay. So I don't know what that is. We may come back to that, but let's hold on to C for right now because at least it's positive. At least it's positive. Does that make sense?
Yes.
Okay. So it could be 20, possibly. Let's plug in 1 over 20. We're going to come back to C. We'll see if we can confirm it here in just a minute. But let's plug in 1 over 21. I want to see what happens. Okay, let me ask you a similar question here. Is that numerator going to be positive or negative?
Positive.
No.
Then
1 over 21 is a very small fraction.
oh.
Think about it for a minute. Like, if you have like 1/21th, 1/21st of a pizza, right? So there's like 21 slices in the pizza.
Oh, okay.
Right? Those are some
That
small
is
slices,
small.
right? And you only got one of those like tiny slices. You have a sliver of pizza, right? That's like an hors d'oeuvre. You know what I'm saying? Like, that's really small. And then you take away a whole pizza? Yeah. You have like negative pizza. I don't know if that helps at all. That's kind of confusing, actually. But you've got something really small, and you take away something more, right?
Right.
You take away something more. If you have half of something, you take away a whole thing. It's gonna be negative.
Okay.
Does that make?
So
yeah.
1 would be the whole thing. You take away that negative 1.
Yeah.
You're talking about. Okay.
Yeah, you're taking away a whole negative 1. Yeah, I mean 1 over 21 is very, very small.
Right.
Very small. I mean, like 1/21st of a dollar is like 5 cents. 1/20th. Well, I know because 1/20th of a dollar is 5 cents. So 1/21st of a dollar is even less than 5 cents. Does that make sense? Why 1/21st is really, 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 really small?
Yes.
Okay. And then if you take away $1, you're great. You got 5 cents. 1/21st. You take away $1, you're gonna have negative dollars in your bank account. Some negative amount of money.
Okay. I see what you're saying now.
Does that make sense now? Mm-hmm. And it's a little bit confusing because you're like, but the 21 is so big. Yeah, it's in the denominator. It's in the denominator. So this is almost nothing. 1/21st is almost nothing. It might as well be 0. And 0 minus 1 is negative 1. So this is just going to be a little bit bigger than negative 1. Does that make sense?
Yes.
Okay. But we've established that it's negative in the numerator, right? There's no question about that. It's a negative in the numerator. Is it positive or negative in the denominator? And it's an obvious question, but is the denominator positive or negative?
Would it be positive?
It's already it's positive, right? There's no negative sign in front of it, so it's positive. So we've got a negative in the numerator, a positive in the denominator. Is a negative divided by a positive going to be positive or negative?
Negative.
It's going to be negative. Because a positive or a negative divided by a positive is negative, just like a negative times a positive is negative. Basically, if the signs are different, it's going to be negative. That's another way to think about it. If the signs are different, it's going to be negative. If one's positive, one's negative, it's going to be a negative. Okay, when we're talking about multiplication and division, which we're talking about here, we're talking about division. So I don't know what this mess is right here. I don't know what it is, but I know it's going to be negative. And 20 ain't negative. Does that make sense, Keisha?
Yes.
Okay. And again, and that's the beauty of focusing on what you know, and not worrying too much about what you don't know. You may not know how to deal with fractions. We're going to go over here in just a minute. But you can find the right answer. I know it's not D. It's got to be C. Just by focusing on what you do know. If you know how to deal with positives and negatives, you can figure it out. Okay? Now, I want to calculate. I want to show you y equals 20. Okay? Let me show you why. So I'm going to plug in negative 1 over 19. And I don't know how many operations we've done with fractions. I don't recall at the moment. That's 1. I mean, you got to remember that, when you're adding or subtracting fractions, you've got to have a common denominator. You've heard that before, right? When you're adding or subtracting fractions, you have to have a common denominator.
Yes.
Okay, you've heard that before. So if I'm subtracting 1, I've got to express 1 with a 19 in the denominator. Do you know how to?
Say it again?
If I'm subtracting 1 from negative 1 over 19, if I'm subtracting 1, I have to express 1 as a fraction with a 19 in the denominator. Okay. Do you know how to do that or no?
Well, if I would have did this from my own, I probably just would have put a 1 up under there.
Here's what you got to do.
Under the 1.
Here's what you got to do. Yeah, I mean, you could do 1 over 1, but still, you need a 19 in the denominator.
Okay.
Here's what we're going to do. I'm going to turn negative 1, I'm going to turn 1 into 19 over 19. Now, I want you to take a look at that. Soak that in for just a minute. Kieja, what's 19 divided by 19?
1.
It's 1. It's 1. It's 1. Okay? 19 over 19 is 1. Anything divided by itself is 1. I think we were talking about it a little bit earlier. So now I've got a common denominator, and I can subtract those fractions. Okay? Now, when we're subtracting fractions, you don't subtract the denominator. You don't subtract the bottom. You just subtract the numerator, right, or add it, whatever the operation is, and you leave the denominator. Okay? So this is just negative 1 minus 19. right? What's negative 1 minus 19? What is that?
Negative.
Negative 20. Absolutely. Right. You're just subtracting the numerators, and then you leave the denominator. Does that make sense?
Yes, that's the answer.
Well, I don't know yet. Not yet, because I haven't divided by. We're not there yet. This is why I love the first way I showed you how to solve it with just the logic. You know what I'm saying? Because like this intimidates a lot of students, and it's tricky. It doesn't always make sense when we're doing operations like this. You know what I'm saying?
Yeah.
So we've got negative 20 over 19 divided by negative 1 over 19. Woo! That's what that thing equals. Okay. So we've got a fraction divided by a fraction. Okay.
Okay.
Do you know how to divide by fractions?
Yes.
How do you divide by a fraction?
Okay. So you would have to think right in my picture in my head. So you would have to that division sign. You had to turn to multiplication and flip the second one.
Yeah, absolutely. Okay. Yep. It's called multiplying by the reciprocal. You're going to take that denominator, right? That 1 over 19, negative 1 over 19, and you're going to multiply the numerator by the reciprocal of the denominator. You're going to flip the denominator and multiply it.
Right.
Okay. Flip and multiply. So, I'm going to work that out just to the right here. So that's negative 20 over 19 times the reciprocal of that denominator times negative 19 over 1. Does that make sense? You've seen that before, I guarantee it.
Yes.
You've seen it before. Okay. This looks a little bit scary, but here's the nice thing. Okay, we're dealing with multiplication here. Okay. First of all, we got a negative times a negative, so we know it's going to be positive, which is great. That's going to be positive. So it could be 20 again. I think it's going to be. Hey, look, I've got a 19 in the numerator and a 19 in the denominator. You know what I can do with those, right?
Cancel them out.
I can cancel them out. Absolutely. As long as it's all multiplication, which it is here. I can cancel them out. They're gone. They essentially become ones. So we got 20 times 1 over 1 times 1. Or I should say negative 20 times negative 1. And what's that equal?
Negative 20.
It's
negative 20.
Well, negative 20 times negative 1.
20.
Is positive 20. Which is what that equation does equal. It's the right-hand side. So 20 equals 20. Woo, that's tricky. That's tricky. Which way do you like better? Do you like the logic way or the operations way?
I like the logic way, but if I would have took this test without seeing how you did it, I probably would have did the second way.
Yeah, but you can
that's what they teach us.
I know. Gosh, I've got so many bones to pick with education. Oh my gosh, I hate the way math is taught. I really do. It's just like do these things and you don't know why you're doing them. It's like, hopefully I did it right. You never know because it didn't make any. Never made any sense to you. And there are times where you just have to do an operation. Okay, I get that. But if you understand kind of what things mean, you don't have to know everything to find the right answer. You just don't.
Right.
And I think that's a better way to look at it. Focus on what the math means. And then you just and then it's just like a little puzzle.
Yeah. And so the logic again, when you had said C was the answer, is because negative 1 over 19 and then the minus 1. The negative 1 over 19 basically is a positive because you got a negative with the 1 and the 19. Right?
Yeah.
Okay.
Yep. Any questions about that?
No, I'm good.
Okay. That's a good review too of adding and subtracting. I guess subtracting in this case fractions, right? You got to get that common denominator. And I think on some of the day one videos, I think I talked about finding common denominators, which is helpful to practice sometimes. And it just you're going to simplify it, and you're just much more likely to find if you can use that logic way and eliminate the wrong ones. And even if all you eliminated is A and B, I'm cool with that. I'm cool. You got a 50-50 shot. It's a coin flip. You got, as long as you're increasing your odds of getting the right answer, you're on the right track. You're very likely to pass this test if you can eliminate 2 of the wrong answer choices from ones you don't know how to solve. You're very likely to pass this test. Okay, let's do some more. Okay. Ah, interesting. Go and read number 6 for us, please.
The amount of money, M in dollars, Paul earns can be represented by the equation M equals 12.5H plus 11, where H is the number of hours Paul works. Which of the following is the best interpretation of the number 11 in the equation?
What are we solving for here, Keisha? Let's make that real clear.
Which of the following is the best interpretation of the number 11 in the equation?
Yeah, what's the best interpretation of the number 11 in that equation right here? Okay. Now, if you're anything like most students, okay, and like me, just looking at that equation, I'm not certain what's going on. I think I know. Yeah. But I think most students look at that and they're just like, okay, M equals 12.5H plus 11. That means nothing to me. You know what I'm saying? It means nothing. Okay. Let's focus on what that means. Okay. M is the amount of money that he's earned. Okay? That's what M is.
Right.
And then H is the number of hours he's worked. So it's 12.5 times some number of hours plus 11. Okay. All right. So what does the number 11 mean in that equation? Let's do this. Let's plug in a value for H. Okay. I'm going to make H equal 1. I don't know exactly what's going to happen here. I'm going to find out here in just a minute. I'm going to make H equal 1. Okay. Now let's think about what that means again here. I'm not just making H equal 1. I'm doing that. But that means that Paul has worked 1 hour.
Okay.
Paul has worked 1 hour. Does that make sense? When H equals 1, that means Paul's worked 1 hour. Does that make sense?
Yes.
Okay, great. Let's plug that into the equation and see how much money he makes when he's worked 1 hour.
Okay.
Okay. Where are you? I'm trying to find you on the question. Where are you at? Are you to the left?
Oh,
you're to the left. Okay, you're good. You're good. I found you. I just found you. You're good.
Okay. So then that'll just be.
Yeah, 12.5 times 1 is 12.5. Anything times 1 is itself. Okay. All right, so if he's worked 1 hour, he's made $23.50. That's what that's saying. Does that make sense?
Yes.
Okay. Okay. Interesting. Let's look. I want to look at the answer choices real quick. Okay, we can plug in a 2, see what happens. We can plug in a 0. We might plug in a 0 in just a minute. Let's look at answer choice A. Okay. Remember, the question is, what is the best interpretation of the number 11? Read answer choice A for me, please, Keisha.
The amount of money in dollars Paul earns each hour.
Okay. So does 11 represent the amount of money Paul earns each hour?
No.
No. We know that because he worked 1 hour, right? We made H equal 1. And he makes $23.50. So 11 can't represent the amount he earns each hour. Does that make sense?
Yes.
Okay. And we're not just staring at this equation and trying to hope to God the answer slaps us in the face. We're just making it concrete with some real numbers. And we know when he works 1 hour, he makes $23.50, not $11. So A is gone. Go ahead and read B.
The total amount of money in dollars Paul earns after working for H hours.
Okay. Is 11 the total amount of money in dollars Paul earns after working H hours?
No.
No, why not? I agree, why not?
Because I don't know how to explain it.
I mean, it doesn't make sense, does it? It doesn't make sense, does it? What's the total amount of money? I mean, it's a variable.
Oh.
Well, here it's 23. You're right. When H is 1, it's 23. Yeah. It's not 11, right? I mean, that's one way to think about it. But it was 23.2350, not 11. So why would it have to be 11? It's not when we plug in a one for h, right? Does that make sense? It's just not. M is a variable, right? That's in fact it says that, the total amount of money he makes is M. And it changes depending on how many hours he works, right? If he works 2 hours, he's making more money. That just makes sense on a logical level as well. Does that make sense why it can't be B?
Yes.
I mean, the total amount he makes isn't 11 because we just plugged in a 1 for H and it was $23.50, not 11. So it can't be B. What about C?
The total amount of money in dollars Paul earns after working for 1 hour.
Is that the best interpretation of the number 11? Total amount of money.
I'm going to say no.
It's no. Definitely no. Right? Because how much does he earn when he worked 1 hour?
Right.
How much?
23.
$23.50. Not 11.
Right.
Does that make sense? Go and read D for me.
The amount of money in dollars Paul earns in addition to an hourly wage. Yeah, that sounds reasonable.
That sounds reasonable, right? Because if we plug in like a 2 for H, his wage is going to go up by $12.50. More than $23.50.
Okay.
Right? If we plug in a 3, it's going to go up by another $12.50 from 2 for H.
Cool.
I mean, maybe a better way to look at it. Let's make H 0. Let's make H 0 and think about what this means again. He has worked 0 hours. He's worked 0 hours, right? He's worked 0 hours. So I plug in a 0 and place that 1. What's 1250 times 0? 0.
12, yeah.
0, right? 1250. Anything times 0 is 0. So that's 0 plus 11. Apparently he's made $11 if he works no hours. So it's like some extra, like you do the job, I'll give you, $12.50, $12.50 per hour plus $11. Okay, so that makes sense.
Yeah.
Okay.
And then I had looked at the keyword, I saw addition, then I saw the plus. I was like,
what do you mean?
When I was reading the question, and then I saw plus 11, so I was saying, okay, that must be an add-on. So
I love it.
I saw addition.
I love it.
Yeah,
I see what you're saying. I love it. I love it. I love it. In addition to an hourly wage. So here's the hourly wage, and there's the $11 he makes in addition to the hourly wage. I love it. I've honestly never looked at it quite that way before. So you're teaching me something. I appreciate that. That's great. That's great. But do you see how you don't have to really think in algebraic terms?
Yeah.
Make it concrete. Start dealing with real numbers. And maybe plug in a 2 and a 3 and just see what happens.
Mm-hmm.
Okay, it's going up by $12.50 every hour. Right?
Mm-hmm.
So then you know what that 12.5 means. That 12.5 means the hourly wage. And then that $11 is just whatever you added on to the hourly wage.
Right.
Any questions?
No, sir.
All right. Again, we're kind of combining that logic and common sense along with plug-in values. And that's a powerful combination. Powerful combination. All right. Let's do... Actually, I tell you what, let's take a quick... No, let's do one more. Then we're going to take a quick break. Is that cool? We'll do one more. We'll take a little break. Let me see. I think that was the last one I just did. Oh, no. I'll do this one. Woo. All right. Let's do this. Go to read number 5 for us, please. Loud and proud.
In the XY plane, a line crosses the y-axis at the point 0, 3 and passes through the point 4, 5. Which of the following is an equation of the line?
Woo! Graphing, huh? Graphing. How comfortable do you feel graphing lines, Keisha?
I hate it.
I got good news for you. You don't have to do a ton of graphing on the Accuplacer. You don't. You don't. There's a way to look at these questions where actually it looks like a graphing question. It's not. It's not. It's not. Because I know. For this, these points here, 0, 3 and 4, 5. For those points, those are x, y values. You know what I'm saying?
Mm-hmm.
Those are x, y values, right? I mean, you always see these ordered pairs. It's x, y, right? So for 0, 3, that basically means when x is 0, y is 3. That's what that means. You know what I'm saying? Is that familiar or no?
Yes.
I don't believe you.
It is.
Uh-huh.
I just hate it so much.
Yeah. Okay, don't worry. But look, just know that's x and y. And right, for 4, 5, that just means when x is 4, y is 5. That's all that means.
Right.
That's all that means. So if they give you one of these ordered pairs like we see up here, 0, 3 and 4, 5, just know, oh, when x is 0, y is 3. When x is 4, y is 5.
Okay.
Does that make sense?
Yes, sir.
And honestly, anytime they give you a graph with like a line, and they give you a bunch of the, like, which of the following is the equation of the line, just take any point, any ordered pair, any set of x, y values, and you can plug them into the answer choices like we can here. Plug them into the equations and see which answer choice gives you a true statement for all the points.
Okay.
Right? Because we know for this line, whatever the equation is, when x is 0, y has to be 3. When x is 4, y has to be 5. It goes through that point. It has to be the case. Does that make sense, Keisha?
Yes.
So let's turn this puppy into arithmetic. Forget graphing. All right? We're going to do some graphing later. We will. But here I want to show you can just plug in values and make it arithmetic. So let's do it. Okay. So let's plug in. I want to see you work this out. Plug in a 0 for x and a 3 for y into the answer choices. We'll start with A.
Okay.
All right. Beautiful. Beautiful. All right. Y is 3, x is 0. Fantastic. Mrs. Tui just brought me some coffee. God bless her. That's right. Here's some solar bread. It's hot coffee. It's good. All right. Is that a true statement?
Yeah.
I mean, you can simplify. Yeah. We can Pemdas it. Do you want to Pemdas it?
Sure.
Okay, great. Then there's nothing to calculate inside the parentheses. Let's do the multiplication first. So what's 1/2 times 0?
0.
0. So that's 0.
Oh,
and then,
I hit writer.
Oh, you're good. You're good. Go ahead. You can finish it. So 0 plus 3.
Plus, 3.
Right.
Which should be 3.
Which is 3. Okay, so A is a true statement. Let's keep it. Let's keep it. Okay, I don't know if it's right or wrong. I don't know, but let's keep it.
Okay.
All right, let's try answer choice B. Let's do 0 and 3 again. Notice I started with 0 and 3, not 4 and 5, because like 0 and 3 is just going to be easier. You know, we could have done 4 and 5. I mean, it's just bigger numbers or more complicated. So plug in a 0 for y and a 3 for x into answer choice B. Let's see what happens.
You said 0 for y?
Oh, sorry, if I said that, I didn't mean it. I'm so sorry. 0 for x and a 3 for y.
Okay.
Yeah. All right, is that a true statement?
Yeah.
Yeah, it is, right? Because that's going to be 3 equals 3 as well. Right? Because 2 times 0 is 0. 0 plus 3 is 3. And 3 equals 3. So we can't eliminate A or B. We can't. Okay? Let's keep it. And I'm glad, look, this is why you don't just stop when you see something good. You know what I'm saying? I think some students using this strategy might be tempted to stop at A. Like, oh, it's a true statement. Done. Got it. You know. It may be right. I don't know. Okay? But when you're plugging in values, I always recommend cycling through the answer choices. Always. Because we got 2 true statements here for 0, 3. Okay?
Okay.
Let's plug them into C and D. We'll do 0, 3 again. So, yep, y is 3, x 6 is 0. Does that give us a true statement?
No.
No, it does not. No, it does not. That's 3 equals -4. No way, Jose. Adios. C is gone. Okay, let's try D. Clear some space. Does that give us a true statement?
No.
No. 3 does not equal -4. Let's go. All right, so either A or B. All right. All right. We got another point, though. We got 4, 5. We can use to test. Okay. So let's do it. Yeah, y is 5, absolutely, and x is 4. Looking good, looking good. What's 1/2 times 4?
Would be 8.
That'd be 2 times
I did
4.
that wrong.
2 times 4. Let's think. Hold on. Let's think of it logically here. Logically, what's half of
2.
4? What's half of 4?
2.
2. It's just 2, right? Isn't that cool that you can just think like, oh, I know what half of 4 is, right?
Yeah.
That's all that means. 1/2 times 4 is half of 4, and half of 4 is 2. Okay. I mean, if you want to think about like the operational way, which you can, remember it's 1/2 times 4/1. 4 is the same as 4/1. Now, when you multiply fractions, again, this is a good review. You multiply across the numerator and across the denominator. You don't have to have a common denominator when you're multiplying or dividing. Right? Again, division with fractions is just like multiplying with the reciprocal. But anyway, so what's 1 times 4?
4.
4. What's 2 times 1?
2.
What's 4 divided by 2?
2.
2. Yeah, that's 2. That's 2. So 1/2 times 4 is 2 plus 3. Does that equal 5?
Yes.
Heck yeah, it does. It looks pretty good. I feel pretty confident about it. We can try B. Let's try B real quick.
Okay.
Let's try B. I just want to, again, I want to, if you can confirm the right one and get rid of the wrong ones, woo, you're in good shape. Well, is that going to be a true statement?
No.
No, it's not. I mean, calculate. It's 8 plus 3, 11. It don't look right, and it ain't. We can confirm and say, yay! You did a graphing question.
Oh, sure. I know this. Like, I forget sophomore year.
Right? Anytime they give you a graph, they give you like an infinite number of points you can test, or almost infinite. Pick any XY pair. Plug them in.
Because how they usually look at it was like the x1 minus y1 over x2 minus y2.
Yeah, don't get fit. Nah, don't get on. No, don't even know. No. I can't keep that straight. You know what I'm saying, Kasia?
Yeah.
Plug in the values. Make your life easier. Pass this test. Okay?
Mm-hmm.
Let's take a quick little break, like 5 minutes. Okay?
Okay.
And then we'll practice more questions, okay?
All right.
All right, see you in a couple minutes. All right, bye.